right, so take a look at these warm-up problems, adding and subtracting rational expressions. We're going to start, as we're going to do most days, with adding and subtracting actual just fractions, because they work very, very similar. So am I allowed to add 2/3 plus 5/3?
Yes.
Why?
Because you have a common denominator.
Good, you have a common denominator. My common denominator is 3, so I take 2 plus 5, which is 7, and I put it over 3. Okay? All right, 1/8 plus 1/10. Now, I know you can do this on your own, but I want you to walk through it with me because I want to kind of model the process we're going to use for the rest of the lesson. Okay, are we allowed to add these right now?
No.
No. We have to get a common denominator. We have to think of it, though, not just as a common denominator, but as a least common denominator. You're going to want the smallest grouping of factors as possible, okay? So the least common denominator of 8 and 10? 40. Okay? So the way I'm going to do this is I'm going to rewrite what I have, 1 over 8 plus 1 over 10. And then I'm going to think about, what do I have to multiply 8 by to get 40? And whatever I do on the bottom, I have to do on top. What do I have to multiply 10 by to get 40? 4. Whatever I do on bottom, I have to do on top. So I end up with 5 over 40 plus 4 over 40, which gives me 9 over 40. So this is our process. We're going to come up with our LCD, and then we're going to multiply by what's missing and combine like terms. Okay? All right. So our instructions are to add or subtract, and you're going to identify any values for which the expression is undefined. So I have x minus 3 over x plus 4 plus x minus 2 over x plus 4. What do you notice about these expressions?
The same denominator.
Yeah, we already have a common denominator. So when we have a common denominator, we can just add across the top or subtract across the top. So this just becomes x minus 3 plus x minus 2 over x plus 4, which simplifies into 2x minus 5 over x plus 4 for all values of x except negative 4. All right, look at 2. Do we have a common denominator? Yeah, my denominator is x squared minus 1, plus 1. So what you've got to pay attention to in 2 is you see this subtraction sign? This is so, so, so important. When you subtract, you are subtracting the whole numerator. You've got to remember your parentheses, or else you're going to really get messed up. So this is 3x minus 4 minus 6x plus 1 over x squared plus 1. Write yourself a big note. When you subtract, you have to put that numerator in parentheses. So what we end up doing is 3x minus 6x, which is negative 3x, and then negative 4 minus 1, minus 5. Okay, where x does not equal what? Yeah, if we tried to set our denominator equal to 0, we'd have x squared plus 1 can't equal 0. So x squared can't equal negative 1. Well, does x squared ever equal negative 1 when we're dealing with real numbers? No. So instead, you can just say x is an element of all real numbers. You don't have to put that down, but I want you to know that we tried to see what x couldn't equal, and it ended up it could equal anything. All right, look at, it's, that symbol is an element of, it's a little like C-looking thing with a line through it. Yeah, kind of like the euro sign. Okay, 2 over 3x plus 5 over 7x. Do we have a common denominator? No. So what I want you to do is think of your denominator in terms of its factors. This is 3 times x. Would you agree? And 7x is 7 times x. Now, when you come up with your LCD, each factor must be represented. So what do you think our LCD is going to be?
21.
Just 21?
Times x.
Good. It's going to be 21x because it's going to be 3 times 7 times x. Each x is only represented one time in each denominator. So you don't have to do anything like x squared. All right, so the way I like to do this is rewrite out your original problem. Okay, and then go through and think about what's missing. What do I multiply 3x by to get 21x? And whatever I do to the bottom, I have to do to the top. What do I multiply 7x by? Whatever I do to the bottom, I have to do to the top. Okay, so 2 times 7 is, good, so I have 14 over 21x plus 15 over 21x, which gives me 29 over 21x. X cannot equal 0. Questions on that? All right, cool. Look at 4. Three over 4x minus 2 over x squared. Think about it in terms of your factors. So this would be 4 times x, and x squared would be x times x. Now this time, do you notice that our one factor of x repeats twice in one of our denominators? Yeah. So when that happens, you would have to include both of those factors in your common denominator. So our LCD here is going to be 4x squared. And it has to be squared in this case because we have x times x in a single denominator. Everyone okay with that? Okay. So this is going to be 3 over 4x minus 2 over x squared. What are we going to multiply 4x by to get 4x squared? Good. What are we going to multiply x squared by to get 4x squared? 4. So we have 3x over 4x squared minus 8 over 4x squared. Anytime, guys, you see that subtraction sign in between your fractions, it's really important you put your parentheses in. I don't want you to forget that. Okay? Even though in this case, does it really matter if you have the parentheses there? No, but you want to train yourself that every time you see a subtraction, you're going to put parentheses. So what is this going to become? 3x minus 8 over 4x squared. What can x not equal? 0. Questions? Okay.
Wouldn't it not equal -1/4 if the starting one is 4x?
So if you take that starting denominator 4x and see when it can't equal 0, you would end up with x can't equal 0. Because you do 4x can't equal 0, so divide by 4. So you get x can't equal 0. 0 square root of 0 is 0, yes. So up here, so it is a pitfall sometimes. If you look at number 2, for example, sometimes people will remember to subtract the 6x, but will forget to distribute this negative, this subtraction sign to the 1. So they'll end up adding 1 instead of subtracting 1. So basically, I'm just reminding you that when you subtract, you're subtracting the whole numerator, so you have to distribute your subtraction sign. Right. Okay? Okay, m over 3m plus 6 minus 4m over m plus 2. Okay. So what do you think we're going to do to start? Okay, in order to figure out what our LCD is, we have to factor each denominator as much as possible. So I'm going to rewrite 3m plus 6 as 3 times m plus 2. So what would our LCD be? 3 times m plus 2. All right. So write out what you start with. I'm sorry? You know this is your LCD because you look at each of your factors from your original denominators. And every factor from the original denominator has to be represented in your common denominator. So 3 is a factor, and I have 3 represented in my common denominator. M plus 2 is a factor, and I have it represented here in my common denominator. Okay? You have to always factor each denominator as much as possible before trying to come up with your LCD. Mm-mm. You're just right about your denominators when you start. Okay, what do we have to multiply that first fraction by?
Nothing.
Nothing. What about the second fraction? 3. So I have m over 3 times m plus 2 minus 12m over 3 times m plus 2. When you see this subtraction, what are you going to do? Parentheses. M minus 12m, negative 11m over 3 times m plus 2. What can m not equal? Negative 2. Questions on that one? Yes, you could distribute that 3 in the denominator, but it's not necessary. No. All right, look at 6. X over x squared plus 5x plus 6 minus 2 over x squared plus 4x plus 4. What's our first plan of action? Factor the denominators. You're always going to factor your denominators as much as you possibly can. So x squared plus 5x plus 6. How does that factor? X plus 2 and x plus 3. You can't use 6 and negative 1 here because then it wouldn't multiply to give you a positive 6. Yeah, those 5 and 6s are always tricky. Make sure you stop and think there. X squared plus 4x plus 4. X plus 2 and x plus 2. All right. Every single time, guys, I want you to be writing out your LCD. That's a really important place for me to check when I'm grading, is that you were able to start off right. So I do want you to take the time to just write out your LCD, okay, like we're doing here. Think about what our LCD would be here. Yeah. So we know we're going to have an x plus 3, right? Now, x plus 2 happens once in the first fraction, but twice in the second fraction. So since it happens twice in one denominator, it must occur twice in our common denominator. So that's our LCD. Is everyone okay with that? Not really? Okay. So if mx plus 2 was just written here one time, then our denominator, our common denominator would just be x plus 3 and x plus 2. But you've got to think, it's already here twice, and we're only multiplying by stuff. So it's never going to go away. So it has to stay in the denominator twice. There's nothing we can do to get rid of it. So if a factor exists twice in a denominator, if a factor exists 3 times in a denominator, it's got to exist that many times in your common denominator. Okay?
Because they have to even out the two denominators.
Yeah, so think about it this way. Here is x plus 3 as a factor, and it's represented in our common denominator. Okay? Here's x plus 2 as a factor the first time, and it's represented in our common denominator. But we still have x plus 2 again, so we have to represent it again in our common denominator. Okay? Okay. So write out what you started with. And then you got to think about each piece. So what are we going to have to multiply this x plus 2 times x plus 3 by? X plus 2. Whatever you do on bottom, you have to do on top. What are you going to have to multiply this x plus 2 times x plus 2 by? X plus 3. All right. You are going to want to distribute your numerators. Okay? So this is x squared plus 2x. Okay, now you can look up here. If during your work, while you're going through the steps of the problem, when you have a long LCD like this, if you want to shorten it and write just over LCD during the steps, I'm fine with that. But pay really close attention to what I'm about to say. If you leave LCD, those letters in your denominator in your answer, I'm not going to give you credit for that. Okay? You can use it in the intermittent steps to save yourself time and space, but your final answer must have your LCD actually written out. Does that make sense? Okay. So this is x squared plus 2x minus, what do I need to do around my numerator? Parentheses, good. As soon as you see that minus, 2x plus 6 over my LCD. Okay, once we have LCDs, what can we do? Yeah, just subtract across your numerator. So we're going to get x squared, and then we have 2x minus 2x. What does that do? It just cancels. And then we have minus 6. And then write out your LCD because this is the end. Can your numerator simplify? No. You always need to check whether or not your numerator can simplify. Megan. Yes, you may write the LCD as x plus 3 times x plus 2 squared. Totally fine. Was that your question, Blake?
Yep.
Okay. Was there another question? Okay, cool. What can x not equal? -2 and -3. All right, number 7. So, on number 7, I want you to kind of be working it on your own. And every couple steps as I'm writing it up here, I'm going to tell you to look up and check your work. Okay? So go ahead and copy it down and then get started on your own. All right, pause where you are. Look up here. Did you get your correct LCD? Anyone have trouble coming up with that as your LCD?
So the only reason that you would do a square is if there was two on the same side.
Yes, the only time you're going to have a factor repeated in your common denominator is if it's repeated in one of the original denominators.
So even though there's x plus 4.
Yeah, so x plus 4 in this case happens once in the first denominator and once in the second denominator, so I only have to represent it once in the common denominator. Okay? Okay, good. All right, go ahead and keep going. Guys, you should be working it on your own. Huh?
I hate that the first thing I when you read a cluster of lines, it's like that accuracy. So weird first. It's happened to me like 5 times.
All right, so look up and check your work. Were you able to get here? Questions on getting here? Okay. From here, guys, it's important to check your numerator. You see how your numerator is a quadratic? You've got to factor that numerator to see if it cancels out any of the factors in your denominator. Okay? So I would come over to the side, and I would say 2x squared minus x minus 3. And I'd go through my factoring steps. I know you can take the time to factor this, but I'm going to go ahead and tell you what it factors into, okay? It factors into 2x minus 3 and x plus 1. Thank you. As I lost my paper. Okay, so at that step, you want to double check. Is anything going to cancel? No, because this is an x plus 1 and this is an x minus 1. So you are more than welcome to leave your answer right here. If you want, you can write your answer out in that factored form. Either one is fine. The only time you have to write it in this form is, say, for example, these cancel. Then it changes your answer. Okay? So you always at least want, some of them you'll be able to eyeball factoring the numerator. If your factors in the denominator were 7 and 12 or 7 and 4, there's no way it was going to end up as a 1 or something like that. You can eyeball it. But if like this one with this minus 3 and this minus 1, you're not sure. It could happen. So you want to come over here and look at it. But either of these are perfect final answers. So that was x minus 1 and x plus 1. You'll never be able to make them the same. But if I had, like yesterday, we had x minus 1, and then we had 1 minus x. And that was the one where we could pull out a negative and turn this into negative 1 plus x, which did turn into that. So it has to be that one sign is this, like this has one positive, one negative, but this has both positives, so you can't make it match. Okay, x cannot equal negative 4 and 1. Okay. Number 10. Go ahead and copy it down. All right, talk to me about our first step.
Factor the
Good. Factor x squared minus 1, x plus 1 times x minus 1. Everyone okay? All right, let's come up with our LCD.
X plus 1, x minus 1 times 2.
Okay, so we've got this 2. Then we've got x minus 1 and x plus 1. It's easy to forget that 2. Over there off by itself. Okay, so be careful about that. All right, I like to write out what we've got. Yep.
How do you know when you put something more than once in the LCD, like x minus 1?
So a factor is only going to appear in your LCD more than once if it appears in a single denominator more than once. So right now, each factor only appeared one time in each denominator. But if, for example, this was x minus 1 squared, then we would have to have x minus 1 squared in our denominator. Okay? All right, what are we going to have to multiply the 2 by? X plus 1 and 2. What am I going to have to multiply x plus 1 times x minus 1 by? And what about this 2? Okay, 2 times 2 is 4 times x plus 1. Good. When I see that minus, I'm going to put parentheses 4 times 2, 8. I know that the parentheses don't make a whole lot of difference here, but you're just training yourself every time you see that subtraction sign. Over my LCD plus, okay, we know what x plus 1 times x minus 1 is. What is that? X squared minus 1. And then can you distribute your x to your x squared minus 1? What's that? X cubed minus x over your LCD. All right, now we just combine like terms. So we have an x cubed. Can we combine that with anything? So we're going to have x cubed, no x squareds, but we have 4x and negative x plus 3x, and then 4 minus 8, minus 4. It's our final, so we do want to write out our common denominator. Now, I have a cubed and then a first degree, so that's not going to factor. But if that was a square, you would want to stop and factor that, okay? X cannot equal plus or minus 1.
In the denominator, do you have x squared minus 1?
You can always multiply out your denominator if you really want to, but I don't think you should ever make more work than you have to do, okay? All right, please look at the bottom of these notes. Guys, this is a completely different homework assignment. Same page, but totally different numbers, so just go ahead and rewrite it. 19, 22 through 27, 35, 41, 49 through 50, and 57. It's the same page as on the syllabus. I think it's 588. Yes, do this assignment. Don't worry about the one on the syllabus.